everybody, and welcome back to our discussion of Chapter 10 on speed. So speed is a natural continuation from our discussion on power. So you'll notice some of these elements are very similar from last chapter. So let's define speed. Speed is taken when we are looking at either the complete linear or angular distance covered, and this is usually a result of reaction or movement. We can break down speed into its component parts. The first one is reaction time. This is usually the time it takes from the detection of a stimulus into the initiation of movement. So reaction times can be conscious and voluntary, and because they are conscious and voluntary, we can improve them through doing skill work with either signal recognition or working to create the most efficient movement patterns. On the flip side, movement speed refers to the ability of the athlete to move themselves, their limbs, or something else at a very rapid rate for a few repetitions. This is usually what we associate with running speed, so this will be almost exclusively what we talk about in class, because this is what really matters to us the most in sport. But speed is mostly determined by genetics. So the muscles you're born with, the skills and upward potential of your genetics are going to be what determines speed mostly. We can do some speed training to a certain level using speed development training. So you may see this quite a bit in long-term athlete development plans. But for the most part, our overall speed is going to be genetically determined. So when we're talking about speed, just like when we were talking about power, our nervous system is going to be a big player in our top speed acquisition. This is usually going to be through either intramuscular coordination or intermuscular coordination. So intramuscular coordination is within the muscle. Typically, we're referring to the relationship here between excitatory and inhibitory input from the agonist muscle, so the working muscle. What is happening in the nervous system that's either exciting this muscle or preventing this muscle from firing. Also within that muscle and its coordination for contraction, we need to look at the motor unit recruitment. Are we looking at large or small motor units, type 1, type 2 motor units? We also need to look at the firing rates of those particular nerves. Is there something that's speeding up or inhibiting this signal? So for example, a reaction versus a reflex. And then we need to look at the synchronization of those motor units through our motor learning patterns. We also need to look at things that could improve our excitatory reflex feedback and minimize those inhibitory reflexes. This is usually done through practice, motor skills development, and repetition. We also have intermuscular coordination. So this is the agonist, antagonist, and synergist or stabilizing muscles all working together to create optimal contraction to produce optimal speed. We want to basically minimize any antagonist co-activation that's preventing optimal agonist activation. And we also want to maximize any synergistic or stabilizing contributions. Usually the way we can get the muscles to coordinate is through practice, and we do this through heavy resistance training or plyometric training. The next two neural considerations we want to look at are reflex potentiation and electromyostimulation. So reflex potentiation is basically an increase in muscular activity that is elicited during maximal voluntary contraction. So this is a reflex increase. This is not something I'm choosing to do. This is putting my muscle in a position where it has to react in a way that is a reflex. So usually the way we try to improve reflex potentiation is to try to improve pre-activation, particularly in sprinting prior to the foot strike. So having that big eccentric load. We talked about this a little bit with plyometric training, where you have the eccentric loading phase, your amortization phase that transitions you from eccentric to concentric contraction, and then concentric contraction, so what we're doing with that foot strike. This is going to allow for us to have rapid force development and then increase muscle stiffness and ultimately have the best muscle contraction for speed development. The second side of this is the electromyostimulation or EMS stimulation. This is a very specialized type of training that is going to use voltage currents through the application of pads to the skin, and particularly over certain muscles and muscle fibers to try to activate the very large fast twitch muscle fibers. If you've ever done STEM in like a training room where they put it on to try to block pain, we can also use this same equipment to work on muscle strengthening. Typically, this is only seen in the physical therapy setting because it's good for short-term increases in muscle activation. It usually is waking those nerves up again after surgery or long periods of atrophy. However, looking at this for the improvements in speed performance, it's kind of questionable. So mostly we use this to improve after rehabilitation or injury because those short-term increases in muscle activation. And then looking at the speed performance, we can get some long-term gross motor adaptations, but usually this is when we are working with, again, people that are dealing with high levels of atrophy or other muscular discoordination issues. All right, so outside of neurological adaptations we need to consider, we also need to look at morphological considerations. So high-speed movements are going to be produced after the performance of two sequential actions. So again, looking at this, we're going to have that rapid muscle shortening in the eccentric phase, leading to energy being stored in the elastic tendons of that muscle. And then we are going to have a high velocity recoil of those tendons when we stretch them again. So think of this like a spring. We store energy and then we release energy. We also need to look at how the body is made. So what are the gross muscle structures that could cause differences in speed and power development? What type of muscle fibers are we using? What are the properties of the tendons? So some tendons we want to be more elastic, some tendons we want to be much stiffer. We also want to look at muscle stiffness. So if you have a very elastic muscle, it's going to give you great range of motion, but it's going to be very hard to generate high force and high power. So you can kind of think of it like a spaghetti noodle. If you have a dry pasta spaghetti noodle and you try to push against something, so representing a very stiff tendon or muscle, you can push something pretty well with a stiff muscle or stiff tendon. However, it doesn't take strain very well. It can snap very easily under certain forces in certain directions. However, if you have a wet pasta noodle, it's not going to handle a lot of force or generate a lot of force very well, but it can take strain. You can wrap it around a fork to eat it. So when we're looking at these properties, you have to look at your movements and decide, am I wanting to generate high amounts of force or am I wanting to have mobility? All right, the next consideration is looking at the endocrine system. Mostly when we talk about strength, power, and speed development, we're mostly concerned with the presence of testosterone. So testosterone, we know, is a sex hormone, and it's mostly used to increase muscle protein synthesis, as well as increase our neurotransmitter releases. This is going to cause nerves to be able to kind of repair themselves a little bit and maybe have some regeneration, and then also improve cell body and dendrite size. So we know once nerves are damaged, they're pretty much permanently damaged, but they can repair themselves a little bit. So you may get some sensation back, you may get some movement back, but this is why nerve damage is very detrimental. But any small repairs that we can get, testosterone tends to help with. Also, testosterone is a major regulator in fast twitch muscle cell maintenance, as well as the main hormone that responds to chronic weight training in both men and women. So both men and women have testosterone present, just men have a significantly higher amount of it. Additionally, we need to pay attention to our other hormones, such as our peptide, thyroid, and catabolic hormones. The main catabolic or muscle building hormone we pay attention to is human growth hormone. This is usually elevated with repetitive sprint and resistance training, and this is usually what helps in combination with testosterone to increase protein accretion and fat utilization. So this is going to help with improving body composition for sprint performance. We also know that sprint training can release cortisol, which is going to break down fats, but it also breaks down proteins. So if you do not allow for adequate recovery after sprint training, power training, or strength training, you can cause the muscles that you're trying to build to break down. Finally, our thyroid hormones are there to regulate the metabolism and promote any androgen responses, so testosterone, estrogen, and progesterone, and try to optimize our strength training. All right, next side of this are the biochemical considerations. So where are we getting the energy to sprint from? This is mostly looking at myocellular energy. So basically what's going to get us the most bang for our buck energy-wise and quickly. Usually we're going to see the ATP and PCR system be used. This is one PCR molecule to create one ATP. It's not super efficient in terms of lots of energy being produced, but it's incredibly quick. And then you also have anaerobic glycolysis, which is going to utilize either glucose or glycogen. And this will give you somewhere between 2 and 3 ATP per glucose or glycogen utilized. So very, very, very quick energy, just not a super efficient system. This is the preferred way to get energy for most of our fast twitch muscle fibers. And because of that, they're going to have greater amounts of PCR. And they can produce anaerobic energy much faster and in greater quantities than our slow twitch muscle fibers. So this is why lots of glucose PCR tends to be utilized in speed, sprinting, and power activities. Also enzymatically, the rate of ATP that is going to be used is really dependent on our ATPase activity. So how much ATPase enzyme is available to break down and utilize the ATP being produced using the PCR or glycolysis systems. Sprint training is going to lead to a greater anaerobic enzyme activity. So more enzymes will be produced and they will work much more effectively the more we introduce sprint training into our exercise plans. This will also increase lactate dehydrogenase activity and increase your muscle's ability to buffer any pH changes and potassium availability. All right, so kind of wrapping up these thoughts, we just talked about some biochemistry. Let's talk about some biomechanics, which is going to be the major player in our next two units. So we're going to look at the ability to accelerate the body. So by definition, speed. This is directly proportional to the magnitude of applied force and inversely proportional to the mass of the body. That was a very fancy way of saying that force is equal to mass times its acceleration. Resistance training is what's going to help improve force production, and it is the best suited way to improve acceleration, which will ultimately improve speed. All right, so as we've talked about in all of our other units so far, we need to know how to assess somebody's speed. Well, it's pretty easy for the most part. We are usually using straight line speed because it's of the most interest in sport. So we can do timing lights. We tell somebody to start at point A and make them run to point B, and we time the time in between. We can do this with frame by frame in video analysis, or we can measure somebody with GPS tracking and radar. This is very familiar in like 5K races. They put the GPS tracker on you, sends you off to run, and when you cross the finish line, it turns it off. So several different ways to do this. All are fairly cost effective and easy for a coach or athlete to use. All right, so final slide, how are we actually going to develop speed in ways that are helpful and practical for the coach and the athlete? Well, the first optimal exercise is any sort of Olympic lifting. These are large musculature movements that are performed at maximum velocity. So think power clean, power snatch, hang clean, hang snatch, push jerk, split jerk, anything that are these big movements. These are going to be hip, knee, and back, as well as ankle extensors. We refer to this position as triple extension. And usually we're using very short time periods to create this. So this is unlikely to cause unnecessary stiffness in tendons, which means we can get efficient elastic storage. So we're not creating brittle, hard pasta-like tendons. So they're staying supple enough to not cause damage, but strong and stiff enough to generate power and speed. Another option is resisted speed training. So anything that involves you trying to run or sprint while weighted, so towing a sled, wearing a weighted vest, running uphill, anything that is going to make the sprinting more difficult. We have seen a direct ability to using this resisted speed training to strengthening sprint form, but you need to be careful that you're not creating other issues with technique like exaggerated trunk lean, which is going to be detrimental when you actually have somebody go run, say, a 100-meter race. All right. And then the third and final option is assisted speed training, also known as overspeed training. This is where we're trying to make the body run faster than it normally would move. So downhill running or being towed. This is going to create a large increase in eccentric loading stimulus, hence why it is called overspeed training. But because we're increasing eccentric load, it means we can also increase injury risk. It does a lot of good things for improving stride rate, but you need to be very careful using this that you don't cause injury to your athlete. So I hope this was helpful in our discussion on speed, and I look forward to seeing you guys back for Chapter 11.